Welcome to Academic Digest class. The question says find the equivalent capacitance for the circle shown below. Also find charge and potential. So when you see this question, the first thing I want you to do is to first of all look at the parallel. I've told you. So what this thing will be is simply taking this now is the same thing as saying let me be drawing this thing small. So simply become the same thing as saying having this way. And I know that capacitance in parallel are done by adding up. So I have 11 and 15. That is 26, Shebi, because 10 here 25 plus 1 here 26, so I'll see 13 microfarad. Please, I'm not converting my own to farad, so I have 26 microfarad. This is how I want you to be thinking of this whenever you see it. So the first thing you do, and the minute you do this one, since it stopped at C4, that means that the next, this one that you've gotten on is C5. So I have this. Then once you do this, you now have your C4 and everything here, and C4 is 14 microfarad. Then remember you have your voltage. So please, another thing I want you to do, always take note of, is that there are some times when your mind will tell you quickly calculate without drawing it fully. Whatever one you are trying to establish, the new one, always draw it fully so that you don't make mistake of maybe adding small part of it. So notice that I've done this now. So the next thing I need to do is to be looking at this one now. So I will move down. The next thing I'll have, if you want, you can do your own by saying, I remember that if it is in parallel, capacitance is given by C total will be C1 plus C2 plus dot 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 up to any number of C. While if it is in parallel, this is for parallel. While for series will be 1 over CT, that is C total equals to 1 over C1 plus 1 over C2 plus dot 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 to any number of Cn. So you need to note this. So if I've noted this, the next thing I will do is to say, since, notice here, everything up here is now parallel to what we have here, but these two are in series. So the next thing I do is to calculate those series. So I'll simply draw it now. Let me check it in series. If I do, that is 1 over CT equals to 1 over 13 plus 1 over 26. Let me quickly do it with calculator to see what I will get. So I will get 1 over 13 plus 1 over 26. It is equals to 0.1154 1 over CT equals to. So you know that anything standing on this one is over 1. Go here, should be, yes. So that CT now becomes times 0.1154 equals to 1. So by the time you move this one down here, you divide both sides by 0.1154. I know somebody will want to say, why didn't you know you do it? I just want you to see how I'm doing it. If you like, you do your own by LCM, no problem. CT will be equals to, so 1 divided by 0.1154. So I'm getting 8.6655. So capacitance total is approximately 7. It's approximately 9. Are you okay? Microfarad. So that means if I'm redrawing this, I told you that it will move in. So if I'm redrawing this, I will now have, it's always important to, and this is going to be C8, not C total. The next one, because we've gotten C5. This will be C6. Sorry, I told you the next one is always until you get to the last one. So this is the next one, C6. So I will have, I'll have here 9 microfarads. That is for C6. So coming down to fix 14 microfarads. And remember that this one is C4. So, and then I have my voltage. The way I'm doing this is the way you should be doing it. So I now have my 18 voltage. So because I know that these two now are in parallel. By parallel, I mean parallel lines. They are parallel. So the next one will simply be parallel. You just do using this formula. You add up. So 9 plus 14. Just carry one from there and put 4. That is 23. So 9 plus 14, 23. So I just have it in this form now, such that it will now be in this form. So, and it will be C7. So C7 will be 23 microfarad. So if I know that, I now have my 18 voltage. So when you know this, you've been able always first of all find your capacitance. If you are doing in between without doing this thing the way I've executed this, when you are doing for combined, you will have issue. So the way I've been able to execute it now, if I now want to find the charge on any of this, I can now be using the principle. Let's say I want to find the charge on, let's say, C1 or C5. I don't have issue. So let's find charge on C1. So Q1 and anything I find for charge on C1 will be the same thing with C5, because they are in series, and charge in series are the same. So I'll say for C1, so Q1, that is charge on the capacitance, for C1, I'll have Q1 equals to CV, C1V. So, and I know that will be the same thing as saying, notice something. First of all, I think the best way to do this, before calculating C1, let me calculate the last one, which is C7. That is total capacitance and voltage. So for C7, sorry, let me go with C7. So when you want to find charge or voltage, always start from the last one so that you backtrack. So C7 times this. So I now have Q7 is equals to 23 times 18. 23 times 18. So 23 times 18. So Q7 is equals to 414 microcoulomb. I'm using microcoulomb because I did not convert the microfarad. So microcoulomb. So if I know this, if you want to convert your own, I can now go back to say, what is the charge in C4? The charge in C4 will be the same with charge in C6. Hold your ear. Always, when you are going forward for capacitance, you go forward. For finding charge or voltage, you will go from back to forward. If you don't do it this way, you will have issues. Let me write it somewhere. Notes. For finding capacitance on a or in a combined circuits, go forward paying attention to converting parallel capacitors to series. Then for finding charge, which is Q, and voltage in a combined circuit, backtrack. That is, go from the last capacitance or capacitances and voltage backwards to be able to easily sort things out. Not like you can't do it the other way, but to sort things out without stress, or with ease, without stress. So I've been able to get the charge in capacitance 7. So the next capacitance, as I'm backtracking now, is C6 and C5. And notice that since these two are C6, since C6 and C4 are in parallel, their charges will be different. Their charges will be different, but their voltage will be the same. So the voltage that you see here, 18V, is for this and is also for this. That means, let me be writing it. So if I want to find the voltage of this one now, remember, for C7 that we see, the voltage there, the voltage, the V is equals to, the V on C7 is 18V. And this is obvious because initially, let's be going, shall we prove anything that requires proving. Okay, so 18V. Now for C6 and C4, Q4 will be equals to 18 times 9, and Q4 will be equals to 18 times 14, and Q6 will be equals to 18 times 9. So let's do it. So Q4 will be equals to C4. C4 is the capacitance 4 is capacitance on the fourth one is 14. So 14 times 18. 14 times 18. So Q4 is equals to 252. Now for yes. So this one is for C4. Now for C6, Q6 will be equals to C6V. So Q6 will be equals to, that is 9. This is C6. I'm putting those numberings to make you know that this capacitance, this one is this one, this one is this one. So 9 times 18. So 9 times 18. So I have Q6 to be equals to 162. Now, how you know that you are correct? To know if you are correct is to say Q4 plus Q6 should give you the total charge, the Q total, which is the same thing as saying 252 plus 162 is equals to Q total. So let's check. So 252 should be 252 plus 162. So 252 plus 162. You see it? So it will give you 414. And if you remember, this is what we got here. So let's put microcoulomb. So it will give you microcoulomb. So to confirm your answer, so you've gotten that. So we've gotten Q7, Q6, charge 6 and charge 4. So let's go and check if there's any other one we are to find. Always backtrack. Going forward you find capacitance, going backward you find charge and voltage. If you are doing it like this, you'll never have issue. So let's go. As we are backtracking, we've done this one, we are backtracking. So to get C5, notice that C5, The one thing that will put you in trouble is a situation where, as you've done one, that you should be sure that you've done it and be moving ahead. Your mind is not telling you, as you are in the one you should be doing, you are going back to check the one you've done. You just carry confusion and put yourself. Just if you are done with one, make sure you are following the principles. Be sure, confirm it before moving to the next one. So I'm in C5 now. Anything I get for C5 will be the same with C1, because C5 and C1 are in series, and charges that are in series are the same. So how do I now go about it? But the voltages are different. So this is where we do the work. And I know that once I get C5, I know that if I get C5, I know that if I get C5, whatever I have as C5 now will be the same. Or if I go to C2, notice that yes, C2 and C3 gave me C5, right? Shebi? Yes. So let me do it this way, because they are in series. I'm thinking. So I'm avoiding. I do this charge times this. Yes, because this is the voltage that was here. So if V times this and times this, but for series it can't be the same voltage, because as it moves here and it moves here, the voltage is drop. So let me focus here. So let's focus here. Okay, so this one is a little bit tricky. Now notice something. We said that charges in series are the same, and notice that those charges in series, we sum these two up by using this capacitance. So this capacitance in series, their charges are the same, so we sum these two up, which means that whatever charge I have here is the same thing with what I have here. So we sum these two up to give me this. And if you remember, we've been able to find this charge, because we can easily use this to find. We've been able to find this charge. So the thing is, after you sum up, and we've made it to be in parallel with this, it's easy to use voltage and multiply capacitance in parallel. So when you do this, because the charges in series are the same and voltage in parallel are the same, so it's easy to multiply the voltage given, because it's the voltage flowing here. But it's not easy to take it and come and put here and put here. They are different. So that means that if this charge here, anything that we have for this charge here is the same thing that is here, because charges in series are the same. So if I have a Q here, a charge here is the same charge that is also found here. The charge here and this charge here is the same. So we sum the capacitance up. We sum the capacitance up. But if we sum it up to get one capacitance to put it in series, because they are in series, these are in series, so we sum it up, capacitance in series, we got the total. So don't take it that they are different. We are able to sum it up using the principle of capacitance to get the total capacitance. The total capacitance in series, their charges are the same. That means that whatever charge I have here is the same charge here and the same charge here. So for that reason, therefore, since C1 and C5 are in series, and the total capacitance is what we have in C6. Hence the charge on C6 is equals to charge on C1 and C5. Notice that C1 and C5, they are the same thing with C6. That is the total capacitance. Individual capacitance C1 and C5, they are the same thing with C6. So equals to charge on C1 and C5, since charges in a capacitor or on a capacitor in series are the same, and you know the reason. I told you the reason. If I have plus, I have minus. Let's see. If you remember, are the same. So for that reason, therefore C1 equals to C5 equals to, what did I get for C6 as the charge? So the Q of C6 is 162 microcoulomb. 162 microcoulomb. Therefore C1 equals to C5, which is equals to 162 microcoulomb. So that means equals to Q1 Q5. So Q1 equals to 162 microcoulomb and Q5 equals to 162 microcoulomb, because they are equals to CQ6. So if I know this, let me continue backtracking. That's why it's important to backtrack. This thing becomes complicated if you are not told that you have to backtrack. So if I know this, I've gotten C1 and C5. Are you seeing it? C1 and C5. Now somebody might want to ask me, what of C2 and C3? If I want to get the charges on C2 and C3. Okay, before I get that, let's check something. Let's get the voltage of this one. So V1, if you remember that Q is equals to CV, that means that V will be equals to Q over C. Remember, and that means that V1 will be equals to Q1 over C1, and Q5 will be equals to V5, because voltages in series are different, so we can find out. So it will be equals to Q5 over C5. So V1 will be equals to 162 all over this capacitance. This individual capacitance is 13. Should be 13. While V5 will be equals to, Q5 is what? Q5 is the same thing, 162 all over. This individual capacitance is 26 over 26. So 162 divided by 13. V1, that is the first voltage, will be equals to 12.46 volts. Then second one will be 162, or V5 will be 162 divided by 26. So I have V5 is equals to 6.23 volts. So notice that it is decreasing. It's almost as if it's always decreased in such a way that the ratios are almost halved. So you need to know that. So this one, as it enters the first one, then it drops. So you need to know that. So that's the voltage. Then for C2 and C3, I'm backtracking. Remember that C2 and C3 gave me C5. Yes, that means that by the time I go to Q1 and Q5, the total of Q1 and Q5, everything is 162. So by the time I come here and say Q2 plus Q3, yes, Q2, that is charge for capacitance 2 and charge for capacitance 3. By the time I check it, the two of them should give me what I have for Q, should give me what I have for this and this, should give me the charge I have here, total of the charge I have in C5. So it should give me Q5. So how do we now find the individual charges there? So let's think. So since we know that C2 plus C3 gave us C5, remember, give us this. So if I know that, I will now say, if that is the case, I now have that this is C2, yes, C2V, because they are in parallel. If you remember, notice this, these two are in parallel, and anything in parallel has the same voltage. And notice that the voltage of C5 is 6.23. So I will now say C2V, and then C3V is equals to Q5. That is Q5's voltage. Q5's voltage is simply 6.23. So that means that I'll simply do this one. Here I have this to be 11. C2 is 11. Capacitance 11. C3 is 15. So I'll just do 11 times 6.23. Then I'll do the other one is then 15. I'll do 15 times 6.23. That is, yes, now so I can do this is C5 times 6.23. That is the voltage. So I now have 11 times 6.23. 6.23, and it's giving me yes, it's giving me Q2. It's giving me that Q2 will be equals to 68.53, and then Q3 15 times 6.23 is giving me Q3 to be equals to 93.45. Let me add it up. 68.53 plus 93.45. So you see that it gives me, if you add these two charges up, by the time you add these two charges up, it will give you the same thing that you have here for V5, which is 162. So 162, that is the Q total, and that Q total is this Q5. So you see that, so sum of Q1 plus Q2 plus Q3 equals to Q5, and that is how you go about it. So we've been able to find all the charges and voltages. I know that if you watch this video over and over and over and over, it will make sense to you. So it's not about rushing to solve something, it's about understanding the methods that is going forward with this, because at this point somebody might want to make mistake and want to use this 18 volts to come and use this and say since they are in parallel. No, that is why you have to backtrack. Thank you. Subscribe to my channel.